my name is ElixXO, Protocol Designer for Dexium. In this video, I'll be showcasing our NFT Hotswap contracts that are currently deployed on Polygon POS. Links are in the description. The NFT Hotswap is a system for easily swapping a non-fungible token with a fungible token, built at a price derived from the relative liquidity of both assets in a liquidity pool. Each swap alters the price of the listing. I'll explain more about the system as we go along. First, we would want to list a fresh collection, but to do so, we require a controller address. We've already listed a collection prior, so all we need to do is take that controller address from the factory contract and use that to begin interaction. This is a limitation with the current front end, which we will amend in the future. And thus, we are greeted with the first listed collection. This menu will allow us to list a demo NFT and FFT. But first, we need to connect our wallet. Now we're going to list a demo NFT and FFT, which we've already inserted into the fields. This will charge us 0.001 Matic. The pair has been created. Clicking the prompt, we are taken to Polygon Scan. You can ignore the yellow warning. Instead, open logs. What we're looking for is the controller contract that was created in the transaction. Returning to the landing page, we insert our new controller. Here we can see the name of the NFT and FFT that we listed and a menu for buying or selling. But what we need now is the liquidity menu. I'm going to deposit some NFTs first. Before we can deposit, we need to approve the contract to spend my NFTs. Once that's approved, we'll automatically get a transaction to deposit. You can see all the NFTs I'm about to deposit. Now that that's done, you can see what occurred in the transaction. NFTs were moved and a liquidity entry was created. And as you can see, the front end recognizes the new liquidity entry. The fees say NA because no trading has taken place, so no fees have been collected. Unlike Uniswap, this system is volume-based, meaning the more volume goes through the controller while my liquidity is in, the more fees I get, whereas Uniswap is time-based. The reason this is so profound is that time is not an accurate measure of work done. When my liquidity is in the LP, it is doing work. With a volume-based fee allocation, a liquidity provider is only entitled to as much work as their liquidity has done relative to their contribution to the pool. Anyways, now to deposit some fungible tokens. How much we deposit determines the price. Note that every deposit or withdrawal changes the price of the listing. Just like last time, I'll first need to approve an amount the contract is allowed to spend. With the NFT approval, I approved all items I owned, but with this, I can choose to only approve a fixed number. Now we sign the transaction to deposit. Now that that's done, we can see the transaction on Polygon scan. In the logs, we can see the actions performed. Tokens were moved from my address to the controller's liquidity, and a liquidity entry was created. Now we can return to the swap menu. We'll set a buy order with a small amount. You can see how much it'll cost me. Currently, you can only swap between a listed NFT and FFT, but we plan on integrating a router that will allow you to do cross swaps from dexes like QuickSwap. This will also allow seamless swapping from the native token, Matic. After approving some more tokens to spend, we can now swap. The dApp will automatically push a transaction to approve tokens if there isn't enough already approved. Now we can see the completed transaction. We can see that the fungible tokens were moved from my address to the liquidity. Price increased as a result, and I got the desired number of NFTs. Now we create a sell order, but note that you need to manually set the slippage above your impact. Impact is how much the price changes based on your order. On Uniswap, this is called delta. Delta is essential for preventing situations where a user buys a token, then immediately sells it for profit. With our implementation, a user attempting this would incur delta on their sell order, resulting in loss. The front end will need to be better optimized in the future to account for this. Now we can see the various actions that occurred in that transaction. You can see I got less while selling. I originally bought 3 NFTs for about 36 FFT and sold for about 24 FFT. Thus, I lost on this trade. Profit is only possible if more buys occur after mine. Going to the bottom of the screen, we can see the factory button. This takes us to the factory contract, where we can see all the deployed controllers. Controllers are automatically verified once deployed. Their code is public. So that was the demo. While we didn't film removing liquidity or claiming fees, since the latter would require a large number of transactions from multiple wallets and isn't quite feasible right now on Mainnet, we do have sufficient testnet logs in our Telegram channel on that. On the matter of withdrawing liquidity, the functionality is quite basic and is explained in the design specs, which can be found on our GitHub. But in short, a liquidity provider ideally is entitled to a maximum amount based on how much they put in. If the price and therefore ratio of tokens in the LP should shift below the user's initial deposit, then they would only receive as many tokens that can be paid out. This functionality was originally designed to mediate the risk of rug pulls, because if more fungible tokens or NFTs are added to the LP, a liquidity provider is not entitled to that, and the tokens instead become excess liquidity that can be used to settle orders. Alternatively, we have a version of this LP system for our DEX concept, Dexion-P, wherein the user is paid a compensation in token B if the amount of token A within a pool is insufficient. This ensures that they always receive nearly or exactly the same amount that they put in and reduces the risk of rug pulls. With that, I conclude. Thanks for watching.